We're asked to solve the following system of equations, linear equations using matrices, which means that we are going to write our system in the AX equal to B format. Remember, A is our coefficients. Notice that we have two variables with two equations, so we're going to have a 2 by 2. I have -7 and 6 in the top row from my -7 and my 6. Bottom row is going to be 11 and -8. So my A is a 2 by 2. X is my variable matrix. I have two matrices, I have two variables, X and Y. I'm going to write this as a 2 by 1. So the Y is vertical underneath, not horizontal to the right. And that's set equal to B, which is our constant matrix, the equal to matrix, 141 and -203. To solve this equation using matrices, we know that X is equal to A inverse times B. But that means that we need to find A inverse. So let's find A inverse. Remember the formula because you have to show all of your work. A inverse is equal to 1 all over AD minus BC times the crazy matrix, where D and A flip-flop and B and C stay put but change their signs. Okay, labeling my little a, little b, little c, little d in my coefficient matrix, my A matrix. I am going to have 1 all over -7 times -8 minus, because it's always minus, 6 times 11 for B times C. Notice that nobody's signs have changed or anything yet. Nobody's position has changed. We don't do any of that until the crazy matrix. A and D flip-flop, which means -8 comes up, -7 goes down. The 11 and 6 stay put, but we switch their signs. Okay. Need to figure out what is going on underneath that fraction. -7 times -8 gets us 56 minus 66, which means that we have 1 all over -10 times our crazy matrix. And now we have a scalar, and that means that we need to take each element in our crazy matrix times the -1 over 10. And in doing that, distributing and reducing. The -8 all over -10 becomes 4/5. The -6 all over -10 becomes 3/5. Then we have a positive 11 over 10 and a positive 7 over 10. But as soon as you get here and you've shown all your work, you stop and you double check it in your calculator. So we're going to put in the original A, a -7, 6, 11, -8. And let's go ahead and find A inverse. We got the correct answers. Awesome. Use your calculator to check your work. You have to show your work still. From here, we know that X is equal to A inverse times B. So we're going to take A inverse, which was 4/5, 3/5, 11/10, 7/10, in that order, times B, which was our coefficient matrix of 141, -203. We have a 2 by 2 times a 2 by 1 which means we can multiply them. We're going to wind up getting a 2 by 1 as a result, which means we're going to take row 1 times column 1. We're going to have 4/5 times 141 plus 3/5 times negative 203. And then we need to take row 2 times column 1. We're going to have 11 over 10 times our 141 plus our 7 over 10 times our negative 203. And again, what's in parentheses should level up. If not, double check what went wrong. And let's go ahead and go to our calculators. We have 4/5 times 141 plus 3/5 times negative 203. We get negative 9. And then we are going to have our 11 over 10 times the 141 and 7 all over 10 times the negative 203 to get 13. We just found X, capital X, as in our variable matrix, but they didn't ask us for the variable matrix. They asked us to solve the system. Remember, our variable matrix was set up in the form x, y. So we just found that x is equal to negative 9, y is equal to 13, and if they ask us for an ordered pair, it would be negative 9, comma, 13.